Yeah. This is good. This looks good. Yeah, this looks good. Right. Morning, everybody. You know what I'm saying? A lovely day. March 5, Friday, as usual. Um, yeah, we're just joining, with another segment of our physics class. In previous classes, we looked at. Let's go. Yeah, we could go back through the slides. Previous classes, we looked at what was physics, and also we took a step further to look at physics compared with other subjects that physics are related to, and finally, we would have looked at Galileo in the previous class. So today, we'll be focusing on measurements, because physics, again, is a study of matter and energy. I think I did 2 videos in that series where we spoke about what is physics, all right? And we also went into various, believe we did, the comparisons there with other subjects. I already said that. But certainly, what is physics? And physics is a subject where throughout the topics that you're doing, the definition does not change, right? The definition remains a constant. So almost like reading the Bible and using and remembering that God is a constant in all of these stories. So I hope that makes it clear for you. All right. So physics is always and will forever be the study of matter and energy. All right. Never forget that. Matter is just a smaller word for the word material. Material refers to things that we have around us as human beings and as living things to interact with. All right, so that's material. So materials could be the what you call air, it could be fire, it could be water, it could be the earth. All right, but as a physics student, they tend to refer to those as solid, liquid, gas, and plasma. All right. So I'm gonna do a little recap here. Should be seeing it on the screen. All right. So it goes back to basics, guys. So we have our fire. Then we have air. Then we have what's this, water, and then of course finally we have our earth. All right. Now I've placed these in a particular order because I wanted to understand something called progression, right? I want to show you how one leads to the other. But I would have done that before, I believe. I'd have to check the archive, but if not, let's start with that. I wanted to always, in every class, understand what physics is all about. Right? Each class is additional information for you to understand the subject more. And physics is a very interesting subject, right? It may be seen as hard by a lot of persons, but trust me, it's I would say it's anything but hard. Requires time and has a lot of detail. And if that's hard, well, it's hard. But to me, that's not hard. And then what persons don't know, and this one it goes mainly to the administrators and the senior educators, that personality affects how you learn. And if you don't know the personalities that you have in front of you as a teacher, then to teach your students now will be a challenge. And the results you're looking for, you will not get unless you understand the personalities. And also the personality of the teacher will also affect how the subject passes from teacher to student. And so these are some issues that we need to remember all the time. All right. And I'm always open to dialogue on these things. I would say I'm a purist when it comes to the way subjects should be taught and how students learn. That's something that I take a lot of pleasure in studying as a lifestyle, not just as a career. So if I were to lose my career, then one thing is sure that I'll still be interested in how students learn and trying to find ways to make it better, to improve it, to add to it, to because this domain of education, it should be for persons who have the passion. All right. So I'm just saying that I take physics seriously, and the passion is what I used to drive me teaching this subject. Certainly not for the pay, but and I mean it does pay the bills, but it's much bigger than that. All right, it's much bigger than that. All right. So anyway, let's go to this segment now. So looking at fire nowadays in physics, we will call this plasma. Don't know if you have heard these words before, but if not, you're hearing them now. Air is generally referred to as gas. These are just the modern names of what we call matter. So matter, 2 T's in matter. All right. Yeah, I've been probably spelling. All right. So there you go. All right. Anyway, so we have these, and then of course this is the old, and this is new. And these are just names. So old names and new names. Water, we generally call it liquid, and of course, earth is solid. All right. Now, in the olden days, when they were referring to materials as these 4 ingredients, I believe it was the right way to go. It was a simple way that people could understand. So you could tell a man, and so instead of having a fancy physics class with a lot of formulas and definitions and taking up notes, these things were before people could write, yet alone speak. If we believe in how human had progressed throughout the years, well, the Bible has a take on it, but then that's a very debatable subject as to how old the earth is and so on. But the point is, the basic materials you are exposed to from you guys born: fire, air, water, and the ground. We call the earth. All right. In physics, we call them plasma, gas, liquid, and solid. All right. So I want you to remember that. No. If you guys have any questions, you can post them in the comments section of this video. All right. So CNAT physics is my favorite subject. I could go on and on about any topic. And I want to share my passion with you guys, right? So I said today we'll be focusing on measurement. And that we'll do because if we have materials around us, we need to be able to measure it. So for instance, let me ask you this question here. All right. How hot is fire? Okay. So fine. Is there anything that is hotter than fire? And if you answer me those questions, then we begin to talk about what fire has that the other 3 don't. So what's the difference between fire and air? All right. Why is it that if there's a fire and you wouldn't recognize a fire by those flames, right? Why is it that air can out a fire? What does air have? What does fire have? What is it that the air does to the fire? These are questions that you should ask yourself as a physics student. If you're not interested in things like that, physics is not the subject for you. And again, I believe in teaching physics from you wanting to learn it or you being curious, right? Not because somebody say you need it to be a doctor or you need this subject for whatever the purpose is. First of all, you need to find out what is it that you want to do, if you like it, and then you take the step. All right, that works for some persons. Some persons know because of their personality and how they learn, they will learn it just the same. But then that doesn't work for everybody. All right, so I want you guys to be curious and inquisitive. Ask the question them. All right, why is air and water a different type of material? What's the difference between the two? And then you could say the same about the earth. So a lot of these questions I'm asking you and throwing out, if you watch shows like Avatar, they would certainly give you a result there in terms of an answer. Give you some clues in, put it that way. I'll call it clues. And very interesting clues. But, you know, you might want to watch Avatar and post your questions in the comments about Avatar, how it relates to physics, because it does love to debate about that. All right. So now our topic today is measurements, right? And this is just a review, a recap. All right. And of course, measurements is our topic. So that's measurements. And I like to do these things live because, you know, I want to speak to you as human beings and not as a person watching a video. I want to speak to you as a human being, as a person, as like a mentor, because that's how people learn, by mentorship. All right. So anyway, let's go to the objective. What is a measurement? What is a measurement? Huh? What is a measurement? Has anybody asked that question before? What on earth is a measurement? Oh my God. Is there any answer for that question? All right. We'll come to that in just a sec, because this is interesting. I'm not gonna leave any stones unturned when it comes to learning physics. So what is a measurement, right? And answer that question. What is a measurement? What is measurement? All right. And it's really interesting to see the definitions that come up. All right. I'm gonna take this definition here and relate it to you guys here. And let's crap this out as what is a measurement. All right. And let's focus here. I hope everybody's seeing this. All right. So if you can see this, we're gonna see what's taking place here. Let's get this out of this. Yeah, that's good. That's better. All right. So measurement, as according to this definition, is a process of quantifying. All right. Let's just make these words simple so you can understand. Process of counting. Yeah. Counting the properties of an object by expressing them in terms of a standard unit. All right, this definition, interesting indeed. Measurement is simply counting. All right, and counting within a certain standard. All right, so it's counting something, and then, so for example, we want to say the amount of heat, the amount of hotness that will come from a fire. We'll have to find some way to count how much heat, you know, is coming from the fire. And of course those properties, that's the property that you'll be measuring. So the thing about it is this: the properties of an object, and I'm going to underline this word because the properties of an object is very important. The properties of an object lead us into something called physical. And this is where the physical, so this is where we start to study so physical quantities. The thing that we can measure. All right. So example here, properties, what can we measure? We can measure the length of it, certainly. Yeah, we can measure the time. Very good. Yeah, we got the time there. We also have the mass. So you know, well, that's another debate because I don't want to say how heavy something is, but it's really not how heavy something is. It's how much the material can resist being taken up. That's different. Anyway, physics is interesting there indeed. All right, length, time, mass, the hotness of an object, we call it the temperature. Could go into an explanation as to why the hotness of an object is called temperature and not just simply called hotness. Well, we use hotness in a different context in Jamaica here, but across the world, maybe it means something else. So, all right. Length, time, mass, temperature, and check this out. We have our electric current. Everybody knows electricity. But let's not call it electricity. We're gonna call it electric current because again, physics is very specific when it refers to things, and if persons don't practice to use the right words where it should be used, then the subject will get challenging when questions are asked, because persons who ask questions, especially in an exam, they know the subject to a point where they will use the words in the right places. If you don't practice to use them in the right places, they ask you the question as how it should be asked, and you are in trouble. Yes, indeed. All right. So let's continue. Length, mass, time, temperature, electric current. Yeah. You know, I remember I did a song about this. Let me see if I remember it. Yeah, I did a song about this. If you're in this track. Yeah. All right. So this is a track that actually I created. You know, and I'm gonna tell you something. Yeah, it goes like this. Length, mass, time, and temperature. Electric current we all measure. Basic units are simply these. Easy to know like bun and cheese, you know what I'm saying? All right. Yeah, right. This is a little freestyle. But anyway, but the track wasn't built for that song, and you know, could not just in time. But anyway, cool. It's cool. You know, not a professional artist, my teacher, so hey, forgive me. But yeah, length, mass, time, temperature, electric current, we all measure basic units are these. So the properties that we measure are the length, but length, we're gonna learn that that's measured in meters. The basic units that when it comes to time is really how many seconds, mass is in kilograms, and we're gonna look at this in details very soon. But I want to focus on the measurement side of things here. The properties. So when I count the properties of an object and if expressing them in terms of a standard, I like this. I like this. Here are our standards. Let's highlight something here, guys, because I want you guys to learn this. I really want you guys to learn this. This is our standard. All right, this is our property. So that's what measurement is, property and standard. Property means what specific thing are you talking about? All right, because it is assumed in this world that everybody have their own property. All right, property is the space that you occupy that you probably own temporarily or permanently, you know, etc., etc. But anyway, but the point is that we have in physics, throughout physics, we are always counting and always having a standard that we use to measure physical things, or where we call them attributes of an object, but yeah, we want to call them characteristics of the object. So we can even measure color as well. The persons don't talk about that. We can measure the color of an object, but that's not taught at high schools. But it's relevant knowledge now, because that will help you now to know the difference between one shade of green and another shade of green. All right. So this is it. It's all about measurements, guys. So I want you to get involved here. All right. Measurements is cool. Measurement is something that you want to get into and understand and be good at it. All right. So again, guys, feel free to ask any questions in the chat or in the comments, and once I see them, I'll get back to you guys. All right. Now, in terms of measurement, though, if we follow in the curriculum, you see in this objective here, express the result of a measurement or a calculation to an appropriate number of significant figures. All right. So, yeah, what we have here, we have our significant figures. When we have numbers, and the point I'm trying to get to you here, guys, is that don't be confused with this information here. I'm going to explain it to you. The numbers we use and figures, and let's break down this word figures. Figures are numbers, and in our system, we start from 0. Next higher number is 1, 2. These are our, order then, if you want to call it that. So we'll count the order. It's interesting. Numbers or figures are given for orders, and orders mean what place or what position something has, and so that's why counting is crucial here. So the moment you begin counting, that's the first thing in physics actually. From you can count, right? You will understand it without a doubt. So let me just put this up to the highest possible figure, which is 9. This is the highest possible figure in physics, math, think in our decimal domain, wherever. But we are seeing in physics that not all of these figures are significant. Well, all right, so significant means that they are showing a sign of value, a sign of an amount. Do we understand that? If we understand that, then we can know why we would consider some significant and some not significant. And then look at this number, for instance. In this example here, we have 0.0050830. But when you're understanding, because the thing about this number is that it's to a person never seen physics before or never using a calculator to a certain level, these numbers will be unfamiliar, but they are real numbers. They exist. They measure in something, and the calculator, it doesn't tell you what you're measuring, but it can measure something. It can be the size of something. It can be the maybe the amount of current flowing through something, whatever it is. This is measuring something, but what is being measured is not there, because check this out. At the end of the last number, there's nothing there. There's no standard. These are just numbers. All right, these are just numbers. So all right. So we have 0.005. Now they have described here the different zeros. Because 0 is a hot topic here. 0 is not always significant, guys. I'm gonna make that abundantly clear that 0 is not always significant. All right, not always. No. So there are some cases where we should look out for zeros. And the first case is looking for the zeros in front of a number. Leading zeros, we call them. All right, leading zeros. All right, I'm going to look at the rules. All right, are leading zeros significant? All right, yes or no? I'm going to answer those questions. All right, also in between zeros, are they significant? Because zeros, this 0 is found between two numbers. And then of course we have zeros that trail and they have non-zero digits. Of course, I'm going to introduce you to the first rule of significant figures. All right, 0 is not always significant, but every other number is. All right, every other number apart from 0 is significant. So from 1 to 9, these are always significant. I'm going to write that here, always significant. All right. These are always counting. 0 is not always counting. 0 is not always counting, but it can count, but not always. We will look at the cases where 0 can be used to count something. Interesting stuff in physics here. All right, but yeah, let's go back. All right, so all right, and then let's carry on. All right, so yeah, so then what we have there. All right, going to the rules for significant figures now. So that is the first rule here. This rule. Look at that. Rules for significant digits, or we could call these figures. We want to be consistent here with our word choices. All right, so figures are digits. All right, same thing. All right, so just as I said before, digits from 1 to 9 are always significant. The second rule says zeros between two other significant digits are always significant. And if we go back to the previous example here, between two significant figures here, this 0 between the 5 and the 8 is significant. We can say that right off the bat. Any 0 found between significant figures are significant. All right. Yeah. So it's interesting, huh? Yeah, very interesting. So like 0 is a little troublemaker when we're counting. It gives trouble. It hides from us, and you have to know how to treat it when it's hiding. All right, you know it's there, but how do you deal with it when it's hiding from you? When it's being elusive. All right. Anyway, so zeros between two other significant figures are always significant. All right, bear that in mind. All right. Second thing says, the third rule says, one or more additional zeros to the right of both decimal place and another significant figure are significant. Now, one or more additional zeros to the right. All right, to the right. I'm gonna go back to this screen here. All right, and show you then to the right. Let's. All right, to the right. So where is our right? That's the question. The right would be here, and of course, what they'll be implying then is that, okay, this 0 could be significant. There's a point there. All right, is that what it's saying? To the left, we might believe it's not significant. Let's just confirm that. Zeros placed solely for use rather, sorry. Number 4 says zeros used solely for space in the decimal point as placeholder are not significant. Very interesting stuff here, guys. I want to go through this another time, but I wanted to look at some examples here. They are saying, and these are just rules here for counting and recording measurements, because in physics you'll be using your calculator a lot and taking measurements, and the calculator is not afraid to push out the zeros before your eyes, and you have to understand how to treat them. 37.300 has 5 significance. Why does it have 5 significant figures? These zeros are trailing zeros. They are found to the right of the decimal point. They are significant. End of story. Have your questions, post them below in your comments. All right, next one. 33.00000. All right, so this has 7 significant figures because there's a decimal point. It's to the right of the decimal point. All right, and we want to go back to that rule here. One or more additional zeros to the right of both the decimal place, all right, and another significant digit are significant. All right, no, and it's to the right. There's a decimal point, so it does make a point. All right, we'll continue in that one. To the other one rather. So all right, so 100 point. Look at that, 100 point. But then this one has 3 significant figures. But check this out. These zeros are towards the left of the point. So is that the rule we're gonna follow? Interesting. It's actually to the left of the point. No, as a rule, the decimal point does help the zeros to be counted, to be significant. Right, the decimal point helps the zeros. Just like in English, is our helping verbs here. the decimal point is a helping thing for those zeros there. So it helps the zeros to be counted. But look at the other one. 100 flat, no decimal point there, has only one significant figure. All right, one significant figure. Yet if I put a point after the 100, it has 3. Interesting stuff here, guys. All right, so let's go to the fifth one. 302,000. No, 302,000 has 3 significant figures. Again, there's no decimal point, and of course, this one has 3 because this 0 is found between 2, and yeah, it's actually found between 2 significant figures. So that rule will apply here. However, these 3, there's no point, and therefore the trailing zeros doesn't have a help. Therefore, it's not counted. They are seen as placeholders in this sense. All right. This is interesting though. This carries us into math and understanding the number concept. Beautiful stuff though. Physics and math are like very, very close. Brothers or cousins or whatever relationship is close. But that's physics and math. Not teaching math, so teaching physics. So move on. 1,050 has 3 significant figures. 1,050 has 3 significant figures. Whoa. This is interesting. And again, it goes back to the rules that we have been following. The 0 is found in between. So you'll be asking me, like, what about this comma? Well, the comma is not a part of it. Some calculators use comma, believe, not all, but the comma is just separating 3 zeros. Usually, it is to let the number, a longer number, be easy to read. So it's a separator, but it's not definitive as a decimal point. Doesn't affect the significant figure rules. So the comma is just to separate, to make a number easier to count. But 1,050, this 0 is in between the 1 and the 5. Ignore the comma. This 0 is between the 1 and the 5. And check this out. At the end, 0, trailing 0. Not making a point, not significant. That's it. All right. So I hope this will help you to understand the rules of significant figures. Now, if you want to test yourself here, here's some practice. There's this 2,000 here. If you can guess how many significant figures would be in 2,000. All right. And of course, let's just make this be 1. This is 2. This is 3. And this is 4. So you can actually pause this video and try. All right, I'm going to try that. All right, we're going to well, try that now, guys. We're gonna go into. All right, let's look at the answers. Yeah, sure. Okay, look at the answers. So what we have here, 2,000. How many significant figures is 2,000? These zeros are trailing, but not making a point. So therefore, you should get 1 for this. All right, and 50.0. This 0 makes a point. So it is indeed significant. All right, so point is there. Again, to the right of it, definitely significant. So this has 3 significant figures. And what we have here, 0.006. All right, if we can just zoom in so persons can get a closer look at it. 0.006. How many significant figures does this have? And that's a very good question. Because these zeros are leading, and the leading zeros are not significant, and so we would say that this has 1. Again, this is a contentious debate there. 1 zeros cannot lead. If you're not counting, if you're not significant, you can't lead. I don't want to get into that debate though. One significant figure there though, I will explain that in a future class. If you have any questions, just hit me up with that one. That rule gives students trouble, but we will clarify that in another video. Next one, the final one for today is 243.0. Again, 0 is making a point, it's trailing. And I want you to understand the difference here. These zeros are leading, zeros are trailing. If the zeros are trailing behind a point, they are significant. But this is trailing. Trailing means that it's falling behind the number, which is where it should be. And if it's making a point, we're gonna say that it's significant. It's okay. All right. So like you could treat it as a child then. All right. So you no wonder persons who are younger tend to be trailing, tend to be forgotten. Same thing with these ordinal numbers. You see, 1 is bigger than 0, so 1 is significant. You have to reach a certain amount to be considered significant. Trading 0, 0, this would have 4 significant figures, and we will go through this. Have any questions, guys? Just don't be afraid to post them. I'll send this in the Google Classroom for Belfield, and you can follow there, ask the questions, and finish the rest for homework. All right, guys. So, yeah. So that's it. So, thank you for viewing this video. You can put a note. You can actually press the bell. You can like. You can share or subscribe. And it's a pleasure for me to be teaching you physics once again. And you can link me up on YouTube as usual. Send me a message or something. DJ Raul, keeping it cool, aka Mr. Finlayson, the official name. All right. So, on behalf of DJRP, I'm saying peace.